Hi, this is James Cook of the University of Maine at Augusta, and today I'm going to walk you through the process of using NodeXL Pro, a software package that attaches to Microsoft Excel, in order to take a look at patterns in Twitter networks. We're going to use three tools. The first is going to be a canned tool of NodeXL called the Top 10 tool. That's a kind of graph metric in NodeXL for Twitter networks. Particularly search networks. But we're going to move beyond the canned kind of metric, and we're going to then take a look at word pairs and how word pairs can create something called a semantic network, a network of meaning. And finally, we're going to take a look at pairs of hashtags and how they co-occur. And that co-occurrence is going to create a hashtag network surrounding a central hashtag, a hashtag that you may search for yourself. As you'll be able to see in this example, it's quite easy to do all three of these if you only follow very simple steps. Now, as you can see here, I already have a set of Twitter data. I've literally just imported it through the import option under the NodeXL tab, selecting Twitter search network, and then looking for the hashtag Paris. I have limited it to the 1,000 most recent tweets. And I have a network that you can see over on the right-hand side, which I could think about and then visualize some more. But what is it a network of, really? It's a network of vertices where the vertices are accounts. What if I want to look for some patterns in the content there? Well, the first thing I could do is that in NodeXL Pro, I can go to Graph Metrics, and I can hone in on top items and Twitter search network top items in particular. If I click on that option, we'll see that we can find top URLs, top domains, top hashtags, top words, top word pairs. All of these are quite useful. And I'm going to calculate those metrics right now. So when I click on that button, you see a progress bar in green as it runs through its calculations for these 1,000 tweets. It can run through calculations for many more. And then we'll get some new tabs. These new tabs are going to include Twitter search network top items, words, and word pairs, and then top items in general. Let's take a look at those. You'll notice here under Twitter search network top items that I am being shown the top 10 URLs in the entire graph. So we will notice that BBC Brazil, Sputnik News, Urbiconica, that's hard to say, CNN in Italy, and the Washington Post are among the top 10 most referred to URLs. And that's referred to also in the top domains. Domains are the main names of a website. So bit.ly is used often, but that's just a website name shortener, so we shouldn't be surprised by that. Moving down, we find out that, not surprisingly, the top hashtags in the tweet for a search of Paris would be Paris itself. But then France, Paris attacks, ISIS, Eiffel Tower, pray for Paris, and so on are included. And we find the top words in the tweets in the entire graph, and then the top word pairs. So the top word pair, which we see here on row 54, is occurring 59 times in the 1,000 tweets, are the two words together, Paris attacks. So a little bit less frequent, but still frequent, is Paris mourns, and then Eiffel Tower lights. This is what people are talking about today on Paris hashtags. Then we can start to find out what are the accounts that are replied to, what are the accounts that are mentioned. So James Woods apparently has said something controversial that people are mentioning. And in the entire graph, who are the top tweeters? The ones that are making the most statements. Okay. So that's what the Twitter search network top items refers to. If we want to take a look at word pairs, we can head to NodeXL Pro and go back to the graph metrics, and let's take a look at words and word pairs. This is the second way that we can start to look at what people are talking about. Let's calculate the metrics there. But first, let's go to options, and let's make sure that we are looking at word pairs on the Edges worksheet tweet, so that the tweet is the content of the Twitter post. We don't want to count by group. We just want to count overall. What are the top words used? And then we're going to hit OK and calculate metrics. And the progress bar is moving forward. Almost done. And now we have a list of words. The most common word, of course, given the hashtag Paris, we're going to find is Paris itself. RT for retweet is the next most common. But we also find French, victims, blue, white, and red. The colors of the French flag are in the top 25. In the top 30, Instagram. We find different ways of thinking about Paris, pray for Paris, tragedy, attackers. As we move down lower and lower, we find some strange, less common connections. Mockingjay Part 2. I don't know what the connection is to Paris. If we really move down to the level of occurring just 3 times, we find atrocities, powers, refuse, accept, CIA, solidarité, avec, which just means with. So we find a lot of variety. In fact, we find that of all the words that occur at least twice, there are how many of them? Well, we can count the rows. 1365 minus 1 for the first row, which is just a header, which means we have 1,364 words that occur at least twice. That's nice, but we can go into greater detail than that. We can look at word pairs. So these are words that occur next to each other. Paris mourns. Credit to Instagram. What? This must be referring to a lot of pictures that come from Instagram. Victims in Paris, support Paris, Paris attackers, and Paris terror. This tells us what? It gives us an idea of what the connections are between different ideas. And each of these word pairs really is a dyad in a new network, a semantic network, a network of words. So, what can we do with that? Well, we could take all of these pairs and let's establish a threshold. Let's just take a look at all those that occur at least 10 times, or perhaps more than 10 times, so 11 or more. And I'm going to copy those, and then I'm going to start up a new NodeXL graph, NodeXL worksheet. And in Vertex 1 and Vertex 2 of the Edges tab, I'm going to paste those word pairs. Now the nodes in the network are words, and the ties are the occurrences of connection between them. But wait, I want to attach one more piece of information too, which is the number of times it happens. Because that's a count that matters, right? It is, in fact, a kind of tie strength. So I'm going to, in other columns, I'm going to paste that in for each of these pairs. And then I'm going to label it number. I'm going to go up here and label it number of pairings that occur. So we know Paris attacks. Those two words are mentioned together 59 times. So we should think about that tie as much stronger than Eiffel and Tower, only mentioned together 11 times in the last 1,000 tweets. Now, if we head over to the right-hand side and we click to show the graph, and I'm going to want to show it on Herald Corin Fast Multiscale, because that's a nice visualization method. Let's see what we get. Wow, take a look at that now. That network clearly shows that there are only a few words in pairs that are isolated. And all the other sets of words in this network are reachable through other words. In other words, this is all one connected component, except for those two dyads up at the top. And that means that there's some kind of cohesive set of ideas represented in these words that create a network of meaning. Well, what is the network of meaning? Okay, to figure that out, let's do a few things. Let's select all of these, and let's lock this format down so that the particular nodes, the particular words don't move too much. And then let's head over to the Vertices tab, and let's use the vertex names, and let's select them, and then let's paste them into the label category so we know what words we're talking about. Oh my goodness. Okay, there are a lot of them. Can we simplify this at all? I think we can. If we take a look through this set, are there any sets of words that are really not meaningful? Well, I see a lot of meaning so far. Here's one. L, which is French for the. So I'm going to delete that. I think that's not really meaningful. And I'm going to delete that there. And then I'm going to go through and I'm going to find, here we have L is paired with Mockingjay and Premier. So I'm going to get rid of it there. And I'm going to look again. And I see that that is all there was. I also see here there is a W in Paris. W is really not necessary. It doesn't really mean much. So I'm going to go back and I'm going to find W. And I'm going to delete that from the network. This is just clarification. So I'm going to then head back, and I notice that in rows 109 and 92 that W occurs. So this is going to take out some ties that really don't have much meaning in them. Okay. And that will help a bit. Then I'm going to refresh. And now I have a very tight center and a very loose set of edges. In fact, the center is so tight, I'm having a hard time actually seeing what's in the center. So what can I do? I can draw out these nodes, some of them out a little bit more, and I can pull, as I pull them out, they're still tied, but they're giving me a little bit more of a chance to see what's in the middle. So I can take mercado and add here. I can take attackers and move identified up. So the attackers were identified. Here's France with news. I'll take TCOT out. That's a conservative hashtag. And as I do this, the words are no longer overlapping with one another so strongly. I'll take that single word attack. I'll let it sit out there. And I'll very soon be able to read most of what is going on in this network. And legibility is really not trivial. It's important. It helps us understand what's going on. So as I do this work, this is work of clarification. Okay, I will be really helping everyone to see a little bit better what's going on. And I'll move that up there. Good. Move that in a little up. And now there we go. We have a Twitter network. When I have it as I like, I'm going to lock it. And then I may want to do a little bit more. If I take this set of word pairs, I can go back to the NodeXL Pro area and I can obtain degree. Why do I want to obtain degree? Because if I sort from largest to smallest by degree, I will find that certain words are lit up more. That is, they have greater degree centrality. They connect more to other words. And then I can take and autofill. I can autofill vertices according to their size, according to degree. And if I autofill there, then I will see the most important words in this network occurring as larger nodes. I can also make the edges appear more strongly when there are more connections that occur for a particular pair of words, that is, they're mentioned together more often. How can I do that? I can look at opacity is one way I could do it. The number of pairings. I can choose that under autofill, the edges tab, edge opacity. Let's take a look at the options. And let's make sure that we have a good range from 10 to 100. And I'm going to autofill that as well. Okay. So now I have some very faint connections that only occur a little bit, and I have some stronger, more opaque connections that appear more boldly, and that means that those pairings occur more often, which is interesting. So this kind of visualization technique then helps me understand what's going on, and I can look at it and I can see some patterns here already. Can you see them? Take a look over on the left hand side and you can see a number of words that are not in English. So they occur together. That is, we can see different language groups talking about the Paris attacks of 2015 in different ways. That's really handy. It tells us that there's a kind of a separation there according to language. Language is important in a semantic network. That's very useful. So there's one kind of network that we can create. And it gives us some meaning. If we further wanted to look at particular groupings, we could unlock all these vertices, and we could use the groups command. We could group by cluster, and we'll use the Closet-Newman-Moore method. We'll put all the neighborless vertices into one group, but I don't think we'll have much of that. And now we'll have a color-coded network, which again we would have to clean up. But you'll notice that each strain of conversation has its own color. So official EU top according nationals, European far identified, and hijackers, or attackers rather, is one line of conversation. Capital, wheel, national, harbor, lit is yet another. The use of color helps us to differentiate further. And that's useful in a semantic network. Let's go back to our original network. This is the network of individuals in the Vertices tab who are connected to one another because they refer to one another in tweets. Now, in these tweets, there are certain hashtags that are, of course, going to include Paris, almost always, in fact, always, because the word Paris is the search term that we used. But you'll notice in the column T that there are other hashtags there too. Now, this is kind of stronger than words, right? So we could think about creating, using NodeXL Pro, a semantic network of hashtags, which are ways that people in Twitter posts, in tweets, talk about what they say their post is all about. If we can think about which hashtags occur together, then this is a much more distilled network of subjects within those who are using the Paris hashtag. So let's go back up to graph metrics, and let's take a look at words and word pairs. But let's select options this time, and instead of selecting off of tweets, let's select off of hashtags in tweets. And let's hit OK. And calculate metrics. And it's calculating, and that'll take just a moment. Well, now when we head over to the word pairs tab, we have a different set of connections. These are now words that are always hashtags. So White House is a hashtag, Paris is a hashtag. Paris is a hashtag, and Parisians is a hashtag. I stand with Paris is a hashtag. These are the subjects of the network. And if we say, let's just select pairs that have pairs of hashtags that occur together at least more than 10 times, which was our standard before, and if we create a new NodeXL template, waiting for it to load, and we paste that in, we will have a very different network, a much more limited network. One that is talking about a smaller set of ideas. What ideas are they? The ideas summarized in hashtags. And some of them occur together much more often than others. I bet you can tell which hashtag this is going to be in the center. Of course, it is the one we searched for, Paris. And you'll notice there's another one over here. It also looks like Paris, but if you were able to look a little more closely, here it would be Paris with an accent, which means that is another language. And, uh, and it is surrounded by hashtags in a different language. So there are a series in this network of hashtags radiating outward from the central notion of Paris, either as spelled by Americans or as spelled by Europeans. So we have three methods for taking a look at patterns in meaning in Twitter networks, and not just relations of accounts. The first is simply to look at top items using the NodeXL Pro Graph Metrics command. The second is to look for word pairs in the content of a Twitter post. And the third is to look for hashtag pairs, pairs of hashtags that themselves create a network of more concentrated meaning, because hashtags don't make up usually the entirety of a post. It's a description of what the post is about. So you now should be able to use these techniques when you use NodeXL Pro to mine Twitter, to take a cup and get a little bit of the fire hose of information that people are contributing to from around the globe, and figure out a little bit from around the globe exactly what people are saying and what they're thinking about an issue of the day.